We have 1, 2, 3, 4, 5 talks before the next break, so settle in. The first talk will be by Claudio Cacciari. That's good. He's from CINECA, and he's going to talk about iRODS workflows for data management in the EUDAT Pan-European infrastructure. He's got a 40-minute slot for a talk, questions, and a demo. Here you are.
Thank you. Okay. Good afternoon. As said, I'm Claudio Cacciari from Supercomputing Center CINECA in Italy. CINECA is part of the EUDAT project, so now I'm going to present what we developed within the EUDAT project about the data management workflow based on iRODS. So I will just shortly introduce the EUDAT project and the challenge that we addressed within the project, the solution, and which involve a service called B2Safe, which is imply extension to the iRODS service, the data management workflow that we designed, and how we implemented the workflow. And then in the end, I will just mention possible future extension of this solution. So the EUDAT project is an European project and built a data infrastructure in the past years. The infrastructure is called Collaborative Data Infrastructure, CDI, is up and running now and is connecting 16 data and computing centers and more than 50 research community, which span across many different disciplines, from humanities to scientific research, from health science to biology and so on. It is a distributed infrastructure across many European countries, as you can see from the map here. And this is part of the challenge that we addressed because we wanted to offer a seamless data management experience to the users in an heterogeneous environment like the CDI, the EUDAT infrastructure, which is heterogeneous from a different point of view, from hardware, software, and policy point of view. And we decided to adopt iRODS as a tool to deal with this heterogeneity, exploiting some of its main features. We defined a common abstraction layer based on iRODS on top of the different storage system in the infrastructure. We offered a shared set of interfaces and clients to the user to allow them to perform, let's say, data management operation in the same way across the infrastructure. We federated different administrative regions of the EUDAT infrastructure, and we enforced a common set of policies through data management workflows implemented via iRODS rules. And now I'm going into details in this last point about data management workflow. So the CDI infrastructure has a service-oriented architecture, and iRODS is part of one of these services called B2Safe, which is dedicated to the long-term data preservation. This is the picture of the service suite of EUDAT. I'm not going into the details now. What is important for the current presentation is just that the B2Safe service is connected to the B2Handle service on top of the picture, which is responsible for the persistent identifier management. I will clarify this relation later. So B2Safe service extend iRODS through the implementation of iRODS rules and through Python scripts. And this extension can be grouped by functionalities, mainly in logging, authorization, persistent identifier management, data replication, error management, and utilities. Same groups that you can see in this picture. And you can see that the logging, authorization, and PID management functionality are the only one connected to external system, which can be just Python script, but in the case of PID management is a real server, bitch-handle server, that I will describe in details. So the data management workflow that we implemented is related to replication, because B2Safe main objective is to enforce policy for the long-term data preservation, and in this context, one of the most important strategies to keep the data safe and to support disaster recovery scenario is the possibility to replicate data in multiple sites, geographically distributed. So we implemented the replication for this reason, and also we gained other benefits in the CDI infrastructure. One is the possibility to exploit the availability in the EUDAT CDI of data storage resources close to computing resources. Many of the EUDAT data centers are also supercomputing centers, so there is convenient for many communities to have this their own data close to supercomputing facility. And the other point is that many communities are distributed across Europe with different institutions, and so it's convenient for them also to have the data replicated close to their institutes in different countries. When we talk about replication, in this case we are talking about cross-zone replication, because we configured the iRODS infrastructure in EUDAT so that each node of the infrastructure is a separate zone, basically. So we, in order to replicate data across the EUDAT infrastructure, we need to replicate across different zones. And we need also to take care of a certain number of issues related to the replication, basically about tracking of the replicas, the fault tolerance, the data integrity, and the performance of the replication. Performance because we are performing replication of massive amount of data, terabytes, 10 of terabytes, and even more in some cases, and also millions of objects. So in both cases, it is important. So we defined many rules, but the most representative one is called EUDAT replication, which is a rule which can really replicate the collection and the data object across the infrastructure. As usual, it can be triggered client-side with just a rule, or server-side in a policy enforcement point. It is a simple, let's say, a rule in the sense that can be invoked with just few parameters as input, source, destination, and a couple of other that I will describe later. But it is the most representative also because it is inside the EUDAT replication rule are called the different other rules implementing the functionality that I have mentioned before, so about data integrity, error management, persistent identifier management, and so on. So how it works, replication? Replication works ingesting data in a EUDAT node from the community. We call it usually the entry point in the infrastructure, so the community usually is related to one of the EUDAT data center, ingest their data there, and then the data are replicated to different nodes in the EUDAT infrastructure. And that's basically how it works, but this is not enough for us because, okay, we can just replicate the bits by bits the files, the collection, but then we need to track this replica, where they are in the infrastructure, what happens when something changes in the infrastructure. For example, EUDAT site could move the location, the physical location of the collection within iRODS, changing the path of the collection and so on, and all these things need to be reflected at the infrastructural level and need to be notified the user because the user then can use the location of the data to exchange this data with other team or to publish this data in a paper or many different users. So we need a way to track all these scenarios. So we rely on persistent identifiers to solve this situation. We have developed one of the functionality that we have in B2Safe. It's the management of persistent identifier, which is implemented through iRODS rules and Python script. In particular, we have a Python script called Epic Client, which is a client for the B2Handle service, which, as I explained before, it's a service for the persistent identifier management. Basically, a persistent identifier here in EUDAT, it's an alphanumeric string composed by a prefix and a suffix, like this one in the picture here. And this string becomes really a persistent identifier when it's published through the B2Handle service, which is a service which is able to make this persistent identifier globally discoverable and resolvable. And this is based on the handle system supported by the DONA consortium. It is possible to associate a certain number of attributes to a persistent identifier, and EUDAT defined a certain a set of these attributes and called it EUDAT PID record profile. This is a group of these attributes that we defined in EUDAT. One is the URL, okay, the location of the object. The other are related to the single object, so the EUDAT checksum and the checksum timestamp, and the fixed content, which is a Boolean variable that basically provides the information about the object. If the object is immutable, it's true. If false, the object could change in the future. And then there are a set of attributes related to the replica of the object. So the first ingested object, FIO, it's a pointer to the ingestion node in EUDAT. The parent field, it's related to a pointer to the parent element in a replication chain. The ROR, it's a repository of record, so it's the pointer to the master copy, even if the master copy is in the repository of the community, so outside the EUDAT infrastructure. And the EUDAT replica is a pointer to the replica, obviously. Now I'm going into details to explain better how we use these elements, these attributes. Basically, you can have multiple replication patterns. You can have replicas of replica of replica, so a long chain, for example. Or you could have replicas of multiple replicas, but of the same master copy, so in a star configuration, let's say. But anyway, independently from the patterns, you have always a certain number of elements that can describe this replication chain. And those are the elements that we defined in the PID record, in the EUDAT PID record profile. So each parent PID record include pointer to the replicas, and each replica include pointers to the parent. In this way, we have a double linked chain in the persistent identifier records. And also we have pointer to the original, the master copy, both if the original is just the object ingested in EUDAT, or even if the original master copy is in a repository outside EUDAT in the community repository, for example. So this is the complete picture here that we have. As soon as an object is ingested in a EUDAT node, we trigger the rule to create the persistent identifier associated to the object, and we register this persistent identifier into the B2Handle service. And we also associate the ROR if the community provides it. And then we replicate the object, and also at the replication site it's triggered the rules that create a set of attributes, the PID for the replica, and the other pointer that I have just described, ROR, first ingested object, and parent, pointing back to the replication chain. So this approach allows us to provide three main benefits. It allows the B2Safe administrator and user to keep track of the replica across the infrastructure. It allows the user to find the replica which is most suitable for them, maybe the closest replica to their institution or for other reason. And in case of failures of one of the nodes in the replication chain, the user can always go back following the replication chain till he finds an available copy. So how can we improve the current work of this replication mechanism? There are two aspects. One related to the architecture. Part of the components of the B2Safe service can be replaced and re-implemented, let's say, as a iRODS plugin. That could be an improvement in terms of performance, for example. And other component could be replaced by the new EUDAT, the new iRODS frameworks, like the messaging framework, for example. And that's for the architecture part. For the data management workflow, we have, beyond the main one that I have presented now, we have other workflow like that one related to the data integrity checks, so the comparison of checksum of the data and the replica across the infrastructure. This is now a separated workflow which need to be configured in a second step independently from the replication and so on and so on. And for example, an improvement could be a better integration of this workflow with the data replication that I have just shown. And so in conclusion, I have explained how we have implemented the two fundamental data management workflow in EUDAT, one for the data replication and the other connected about the assignment of globally discoverable identifiers. These two are building blocks that can be used by the community to build more complex and customized policy for the different communities. This is the list of developers of the B2Safe service. And that's all for the presentation. So I don't know if you want to ask me a question now. I have also a short demo about the replication mechanism. As you want, I can also go on with the presentation, with the demonstration, and move to the question later. Okay, I will go on. So, I'm now connected to the iRODS and B2Safe service deployed in CINECA in Italy with my normal user. And okay, I'm connected through the iRODS interface. So I can now, for example, upload an object. Whoa. Okay, I need to use also the two hands. Okay, better. Okay, so let's, for example, copy, so ingest one object inside my folder in CINECA. Okay, let's check also VI command, what is available. Okay, so I have my object in the testing folder that I have prepared. And we can also check that this object is now without any metadata associated. Okay, none. So now I'm going to create a PID and associate this PID to this object. Using one of the rules that we have developed. Here I have copied the rule for convenience. Okay. Okay. So this rule now I'm triggered client side for convenience, but it can be obviously triggered also in a policy enforcement point. Now I can check again the metadata, and I can see that I have created a set of metadata associated to the rules. In particular, we are interested in this one, the PID. So we have a prefix here and a suffix. This is the prefix of the CINECA Institute. But this is not enough for us. We also want to check that this is global, really globally discoverable. So I'm going to the global resolver web interface of the handle system here. And okay, I get the set of attributes available, and with the EUDAT checksum timestamp and fixed content and so on. These are the set of attributes for, let's say, the single object itself. So far, no replication has happened. So going back to the WebDAV interface, you can see that there is a folder called test PID Replica 1, which is empty. Now I'm going to replicate my object there. So I have also, yes, one other rule here. Okay, I can just issue it. So what I'm going to do now is to execute this rule here. Okay. Basically, this rule is the replication of my original test data to the test PID replica folder. I'm invoking the UGM2017 replication rule, and yeah, with the recursive register parameter set to true, but this is not so important now for the single object. They are related to the replication of a collection. Okay, so now I'm going to invoke this rule. And okay, success. So I expect to see something in my folder now. Okay, the data has been replicated. But this is not enough. We want also to check about the PID. So we can, for example, copy this line here. Okay. And then you can see that we have other attributes associated to the replica, also the parent, ROR, and first ingested object, which are all the same in this case because they are pointing to the first object that I've ingested in the EUDAT infrastructure. And as usual, the PID. This is the PID of the replica. Again, I can check that this PID is available from the HDL site. Okay, also this is available and with the set of expected attributes. And so it works so far. And then we have also the possibility to replicate a full collection. So now we can see that in the main folder there is just test PID replica 1, but no other test PID replica. So now I'm going to execute this second rule, which basically replicates the collection test PID replica 1 in 2. In this case, the parameter recursive and registered are meaning that I'm going to replicate recursively any subcollection inside the one, and that I'm also going to trigger the creation of PID for each object inside the collection and each sub-collection, because there are scenarios also in which we create just, for example, persistent identifier of the single root collection and not of the object inside. So this is possible. It depends on the, let's say, community requirements. And now I am going to test this. And now I'm expect to see again a new folder, new collection here. And that's it. That's PD Replica 2. So I replicate the collection and the object inside. And I can also check the metadata associated to the collection. No, okay, I forgot to change here. It is a collection. Okay. So now it is, you can see that also associated to the collection I have a set of metadata, and I have a PID. And even in this case, I can check in the handle system. Yes, here. The set of attributes associated to my persistent identifier for the collection here. You can see here that the main difference in this case is that there is no EUDAT checksum or checksum whatever, because it's a collection, so it does not make sense. And that's it. So I have shown more or less the main aspect of the replication and persistent identifier management in the EUDAT data management workflow. So now, if you have any question.
So why it looks as if all the PIDs are the same, the parent and the ROR and itself?
Not always. This is because this is one-step replication, so they are pointing just to the same parents. But if I look, for example, to the metadata of the second replication that I have performed, you can see here that the ROR and the parent are different, because the parent is pointing to the parent object here, while the first ingested object and the ROR are pointing to the master copy, the original copy here.
Excellent. Yep.
Very nice presentation and a nice demo. What I like about it is the relationship that you bring between these replicated objects and persistent identifiers. What I missed from your presentation is how do you deal with versioning of files, and do you then assign a new PID to the new version of the file, or do you have other strategies?
We haven't implemented a specific function for versioning in the B2Safe core. We designed the B2Safe core in order to support different strategies. The fixed content attribute that I've shown, that is here, for example, true, it is related to this strategy because, okay, if it is true, the user that want to rely on the PID can be sure that the content of this file associated with this PID will never change, because this is the policy that we adopted for this specific object or collection. This is obviously an agreement with the community. We ask the community what they want to do with their data. And if it is false, then the content can change. So in principle, if it is true, you can associate a new PID to each new version of the object that you upload in iRODS, because you cannot modify the old one. But other communities say, no, look, we are not interested in this. We want to update the content of the object, keeping the same PID. So in this case, we put this Boolean value to false, and you know that the object can change in the future. So it depends on the different communities. We receive many different requirements, and so we need to adapt a bit to the different. Potentially, it's possible to implement versioning in both cases.
Okay, thank you. Okay.
Well, thank you very much.